Good afternoon, everyone. I would like to thank you all for joining us today in our continuing education series. Today our featured topic is an overview of cleaning connectors. My name is Jessica Petrahoy, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. Every fiber optic installer and technician should understand proper cleaning procedures. Often the cause of a network outage is simply connector contamination. Always inspect, clean, and inspect again before you connect your connectors. Today Terry will be talking about the do's and don'ts to fiber optic connector cleaning and the various products and methods used to ensure proper cleaning. So at this time I would like to introduce Terry Power. Terry is one of our senior instructors and an outside plant technician with over 25 years in managing networks. When Terry is finished, we'll be taking questions from the GoToWebinar chat box. Thank you again for joining us today, and at this time I will turn your presentation over to Terry.
Thanks, Jessica, and good afternoon, everyone. Again, my name is Terry Power. I'm senior instructor and primary traveling overseas trainer here at the Fiber School at fiberoptic.com. And as Jessica said, I've been in the field for about 25 years now. I started in 1987 working in cable television after coming out of the Air Force, and made the migration over to fiber as fiber grew up more and more in the coax industry, and ultimately ended up in 2007 as outside plant coordinator for Tele Barbados. Tele Barbados sent me to the fiber school to get some certifications to go along with the work that I had already been doing, and I struck up a friendship and a relationship with the boss here, the president of the company, and 2 years later when my wife and I moved back to North America, he put me on salary, and I've been with fiberoptic.com for about 5 years now. So, and work with developing a lot of the training and webinar type of programs. So with all of that said, today we are going to talk about connector inspection and cleaning. And let's get this started. So we're going to talk about the connectors themselves, looking a little bit at the connectors and some of the issues with cleanliness. We're going to look at a little bit of the equipment that we use for inspection, some slides that will demonstrate what we are looking for and what we're looking at on these connectors. We're going to talk a little bit about dry and wet cleaning techniques, a few testing tips, and at the end of the presentation we'll have a question and answer session. So if you'll save your questions or go ahead and make a note in the question box, we'll get to those at the end of the presentation. So, looking at the connector itself, as you can see here, we've got an LC connector plugged into a bulkhead adapter, and you can see the ferrule and the alignment sleeve that's going to make the two ferrules line up so perfectly that 8-micron cores line up perfectly one across from the other. That still blows me away. I still get a little bit baffled at the precision of the technology that allows those alignment sleeves to line up two ferrules. When we plug in the other side, the other connector comes in, the ferrules have a physical contact in the center, and that's where the transmission of light is taking place. The connectors are easily the weakest and most problematic point in any fiber network, and that's why cleanliness is so critical to this process. So the 3 P's of a good connector: perfect core alignment, physical contact, and a pristine connector interface. Now the technology today and the techniques used for production have pretty much eliminated any of our concerns about core alignment As I said in the previous slide, I get kind of excited about that precision. That precise alignment of the cores is taken care of. Physical contact, the new polishes, the UPC and APC polishes, provide that physical contact very nicely. What we have to worry about as field persons is the pristine fiber interconnect. That Endface has to be perfectly clean. And if we don't have that perfectly clean, that little bit of contamination is the #1 source of troubleshooting. In my experience, one in particular traveled to Haiti after the earthquake down there. They called us down to do some testing and repair. Got down there, did some testing, had high reflection levels, started cleaning up the connectors, retested. Everything was nice. The reflections were way down. The fiber actually looked pretty good. We started plugging stuff in, and they called to see what we had done, because in that little bit of cleaning, we had removed 90% of their intermittent issues that they thought were bad fibers. So I've seen firsthand how cleaning can go from an intermittent failing connection to everything stabilizing and working perfectly. And a single particle into a mated pair can cause the air glass boundary, a significant back reflection, and a tremendous amount of loss. As you can see from the illustration with the dashed line coming back, that's the reflection, and you see the line going forward is greatly diminished. So not only do we have the significant reflection and the insertion loss, but it's important to note that that much back reflection can actually damage high power lasers. And then you've permanently damaged your transmitter, and the costs associated with that are phenomenal. So, some of the equipment that we use for inspection. Now personally, because I like my eyes and don't want spots in my vision, I'm particularly fond of the self-contained probes. A probe like this one that is connected to a standalone display unit. It also allows you to save the image so that you can demonstrate as a contractor. As an example, when I'm out doing contract work, I take pictures of all the connectors so that I can demonstrate that it was clean when I left. So if there's ever a question, no, here's the picture, I sent you this picture, I'm clean. I like those kind of units. I also like the standalone unit like this that actually has a USB port. And one of our testing jobs down in Guatemala, we were running around with a laptop and this style of USB probe and just doing pictures of connectors. So it gives you a great deal of flexibility. And it also protects your eyes because it's a camera looking at the fiber, and on the outside chance that someone plugs something in while you're inspecting the fiber, you're protected from the laser energy. These little handheld units are great if you are using checking the connectors on patch cords. If you've got both ends of a patch cord, you're reasonably well assured that there's no light being inserted. And these little handheld units are perfect for that kind of quick inspection. We use them in our classroom when we're teaching installation of connectors onto patch cords in our installer course. We use these pretty extensively because they're quick and easy to use. So, I'm a firm believer in all of these products, each according to your need and what is appropriate for what kind of work you're doing. These probes usually come either 200 power or 400 power. It is absolutely seriously recommended I won't say critical or vital. I use those words too much when we're talking about cleaning. But I will say that it is highly recommended that you use a 400 power on single mode. Some people will say that you shouldn't use 400 on multi-mode. I'm going to differ with that. I think the 400 power, you get one scope and you use it. 400 power, okay, so you see stuff on a multi-mode connector that you can get by with, but we're human beings and we're capable of making the decisions for ourselves. And 400 power gets up close and personal. You can tell what's going on. And again, this slide recommends the video probe for an OTDR or USB port. And again, that's the same thing about visually, or protecting your eyesight. I'm a huge believer in safety. Some contaminants, some of the things that can cause us to have the failures. And some of this is a little repetitive because we want to drive home a point, but a particle that partially or completely blocks the core will generate huge back reflections, can cause instability. Now with a high power laser, if you're lucky, the laser will turn itself down out of self-protection, and it will have some mechanism for doing that. If it doesn't, it very likely could eat itself. Lasers don't play well with light being shined back at them. And a serious amount of back reflection is going to cause either a failure or the laser to turn itself down, which is going to cause a tremendous amount of instability in the system. Dust particles trapped between the two fiber end faces can scratch or embed the surfaces. In fact, with a strong enough laser, you can actually burn the dust into the end face of the glass. Permanently damaging your connection. And if that's the ferrule on your launch, that could be a whole piece of equipment that's got to go back to the factory to get refitted with a new ferrule at the launch connector. So all of these are certainly issues. A 1 micron dust particle can block up to 1% of the light. A 9 micron speck, still too small to see with the unaided eye, could completely block the core of the fiber and cut off all communications. So you can see how even a small amount of dust can be a huge problem at a connector. In addition to dust, there are other contaminants, oils, skin oil. I see people touching the end face of a connector with their bare hands more often than I should. And I cringe every time. And being a trainer, I want to correct them, but usually it's not my job. I just have to go clean up behind them. But skin oil will cause a nice residue layer, and any kind of wet contaminant will attract dust. So it just just builds on the problem, magnifies it. Film residues condensed from vapors in the air, cleaning solutions that are not dried off, that are let to air dry, can also cause powdery coatings or sometimes a filmy residue. So all of these are things that we're going to talk about, and I'll show you some examples of connectors in the next section. So again, high-powered lasers will possibly burn a contaminant into the end face of the glass, and it's ruined. If you're lucky, that's a connector that you can replace and not the launch connector on the piece of equipment itself. And again, those kind of reflections can permanently damage the laser. So we're always trying for a totally clean and pristine end face. And as Jessica said in her introduction, we want to make sure that we inspect, we clean, and we re-inspect before we plug that connector in. Now, the last thing it should do is be in the inspection probe, visually demonstrate that it is perfectly clean, and go straight from there into the connector. And there should be no in-between steps. All right, so real quickly, going to show you what can happen with these 10, 11, 15 micron pieces of dust. This is actual contamination, and these are actual pictures that were taken after each mating. You plug in the first time, and there is a huge amount of pressure as that clicks into place and drives a huge force against a 250 micron or 250 micron, no, 2.5 millimeter. I apologize. A 2.5 millimeter or 1.25 millimeter, that little bitty face with a huge amount of pressure, it shatters any kind of particles. And you can see after the first mating, the particle migration. Mate them again. There's the second time they've been mated. Third time. By the fourth time, these three little particles were mated. By this point, we've actually chipped and embedded some of the glass or some of the dust into the glass surface. And this is unusable. Anything less than 5 microns is likely to embed into the fiber surface, and you can never clean that. You can't polish it out, it's done. And so you're going to be replacing connectors. All right, so a clean connector. Clean connector should look like this. You see the core and the cladding. Now, of course, the core is not always going to be illuminated. You won't always see it. It will depend on the environment that the other end of the fiber is residing. But a clean connector should have no dust, no scratches, no marks. It should be free of all dirt, scratching, oil, any kind of residue. Minor defects are allowed on the outer cladding. So you can see a little bit of the epoxy ring right here. Those are allowable, but nothing much more than that. Some examples: dirt. That one's kind of obvious. Alcohol residue that was left to air dry. Scratches, that one's kind of obvious. That one looks like somebody took sandpaper to it. And skin oil. Now, believe it or not, that is a fingerprint. That's all that is. That is one time somebody touched the end face of the connector with a bare finger. And those are the ridges and grooves of a fingerprint. All right, this image shows a connector with dust particles spread pretty evenly across the surface. This one needs serious cleaning. This is some sort of liquid contaminant. It just needs to be cleaned. Here's another image that's showing a liquid contaminant that needs to be cleaned. That one looks like skin oil as well. Here's small droplets of liquid. This looks like somebody took a swab and cleaned and didn't dry it out correctly. Alcohol residue. Another looks like a swab signature. This looks like it's dried on there and is residue that needs to be cleaned off. It's probably going to need another wet cleaning before this can be usable. This is oil residue from wiping a second or third time on the same cloth. Once you use a wipe, you need to throw it away. Don't touch the wipe with your fingers. I see this one in the classroom all the time. That one could very easily be from one of my students that hasn't learned to clean properly. They'll keep that one little piece of cloth there, and they'll clean the connector, and they'll bring it to me, and then they'll go polish it some more, and they'll clean it again and bring it to me, and pretty soon It's got their skin oil on it, and it gets transferred and smeared, looking very much like this image here. Scratches. In this case, the scratches are probably not as critical as they could be. None of these scratches actually intersect the core, and this connector could probably be cleaned a little bit and continue to be used. I would double check reflections through this connector, but if you're getting high reflections, you're going to end up replacing it, but I'd give this one a shot. But just be aware that those scratches close to the core are where you're going to start getting into problems. This one is chipped, as you can see on the right-hand side of the image, and it's got a huge epoxy ring telling me that this is a hand-polished connector, and that they're trying to polish down below the end face of the ceramic ferrule, and that one will never be cleaned. You see an image that looks like this, just go ahead and replace it, because no amount of cleaning or polishing is going to fix that. This image is an LC connector that has been chamfered on the edge of the surface, the contact surface, and this one is going to have to be replaced. You'll never be able to clean that up, and that'll never make the proper physical contact to line up. So, with a few of those images in your mind, we're going to talk about some of the cleaning procedures. We're going to look at this kit. This is a pretty good variety of cleaning tools, from the alcohol prep pads that are pre-moistened, a cleaning solution, clean wipes, swabs of different types, and a cartridge cleaner with a replacement cartridge. And then these are some other cleaning supplies for some chemicals. This one is for taking off icky pick from bare fibers. And the other tool that I love is the quick click style of connector cleaner. This gets up inside a bulkhead better than anything else. And a lot of the jobs we go on, particularly for the testing division here, we'll go out and we're presented with a bulkhead and say, you're testing from this to patch panel, however many miles from here. And we're not allowed to get behind it and unplug to clean. So we need something like this quick click that will go up inside the connector and into the alignment sleeve and clean the end face of the connector on the other side. And I like these because it sweeps out any debris at the same time it's spinning around, because of the manufacturing process. And there's a little, I call it fuzzy dental floss. It runs down the center and then out and then back up, and as it rotates to clean, that is also advancing and sweeping stuff out, as opposed to the swabs, which unfortunately can from time to time become more like a ramrod. So the decision-making process for your connectors. We're going to start off, we're going to put the end face of the fiber connector into our inspection probe or microscope, and we're going to decide, is this clean? If it's clean, plug it in. And if it's not clean, let's go to a dry cleaning process, either a cartridge cleaner or some similar dry process, clean wipe. And then we inspect it again. At the decision point, is it clean? Okay, plug it in. If it's not clean, we're going to try to dry clean it one more time. Then we inspect it. If it's clean, we plug it in. If it's not, then we go to a wet, followed immediately by a dry cleaning. You do not want to let any cleaning solutions air dry. Then we're going to inspect the face again. If it's clean, of course, we plug it in. If it is not clean, we repeat the wet cleaning, wet-dry cleaning, 2 or 3 times. There's going to be a point of diminishing returns where you just decide this is not going to get clean. But this is the decision tree. Give all of these a try before you replace the connector. But always remember, you inspect the connector, you clean the connector, inspect it again. Make sure it's clean before you do the actual connection. All right, some of the methods and tools. You've got isopropyl alcohol, 99%. It says on the slide nothing less, but I know the practicalities of the real world, and sometimes 97, 95 is the best you can get. I typically go to the local pharmacy and ask for surgical alcohol, and that's going to generally give you the highest concentration available. 95 will do if you have to. 97 is better. Of course, 99% isopropyl is the standard and is the ideal. Lint-free wipes, any other cleaning chemicals. You might have a cleaning solution that your company prefers. And any good kit is going to include alcohol, wipes, a scope for inspecting. Remember, you inspect, you clean, you inspect again, then you connect, so you always want to have some method of inspecting the connector. And then whatever cleaning tools. Dry cleaning. Clean the Endface with a lint-free wipe. It could be a cartridge cleaner or just a loose wipe. Or in the case of this illustration, you can see a swab being used on a bulkhead. Never use the blow-dry method. And I've heard the blow-dry method used to refer to 2 different things. The slide's talking about canned air. We'll come back to that in a second. I also see the blow-dry method where someone blows on the connector and wipes it on their shirt. And I know some of you guys are out there laughing right now, but I've seen it in the real world. And you'll see, I couldn't believe it. I actually saw this guy just and wiped it on his shirt. Again, I was a contractor doing some work in there, and I wasn't in a position to correct the individual. So I just shook my head, left the building, and when they finished with their work, I went back and cleaned up before I started testing. Because, damn. Anyway. The reason you don't use canned air is that the canned air is pushed by a propellant. It's not just pressurized air. There's a propellant, and that propellant will leave a residue. So the canned air method is pretty much pointless. You're going to have to clean after it anyway. So again, all connectors should be cleaned before testing. Wet cleaning could include chem wipes and isopropyl alcohol, the pre-moistened alcohol wipes, any kind of connector cleaner. I like the cube here. It's listed under dry cleaning, but I like it because it has a rubber pad. I have taken these in the field any number of times. I can moisten a corner with the cleaning solution, wipe a few times, dry it on this section down here, and I've got a rubber pad I can push against to get a little bit of extra friction. And then, of course, you always want to dry it after you use any kind of cleaning solution. And the dry method includes any kind of loose wipes, the cube, as I've already talked about, or the Cle-Top, or any kind of cartridge cleaner. All right, cleaning sticks. I have mentioned those when we were looking at the earlier picture. If I've got to do wet cleaning, I will moisten one of these and I will use it for cleaning. I will immediately go in with a dry one and do my best to dry up any residual cleaning solution. As I've mentioned a couple of times, anything wet left inside the bulkhead is going to attract dust. It's going to attract dust more readily than a dry connector. So you want to make sure and dry up any of your cleaning solutions. Also, when these cleaning solutions air dry, they will leave a residue. Both of these are bad ideas. Make sure everything's dry. Now, if I'm doing just dry cleaning, I'll use the one-click because, again, I like them. They sweep out any kind of debris and pull it out of the connector or out of the alignment sleeve, whereas cleaning sticks have a tendency to just become a ramrod and shove stuff down in there, spin it around, and you're over on the sides off the contact surface of the connector, but you still got contamination that could migrate. Now, cleaning fluid. You got to be careful what cleaning fluids you use. And I put this picture in here mainly because I love this stuff, but it is hard to travel with. And I do a lot of traveling on airplanes, and airlines don't like this label right here that says caution. You know, store in a cool place, may blow up, or something to that effect is what it says. It's extremely flammable and it will go boom. So airlines don't like to have it on their airplanes. They're funny that way. So I end up using a non-flammable cleaning solution. It's also easier to ship ahead and that sort of thing. I put this in here only because it is simply the best there is, even if it's not practical in this day and age. Never allow the cleaning alcohol to evaporate. We've talked about this. That air drying, it never completely dries, or it takes it a lot longer. It will attract dust and leave a residue. You've got to clean off anything wet, dry it off before you make your connection, and liquid alcohol will get into crevices, cavities. It's going to find a way to hide from you. So be diligent in your cleaning and your drying off of the liquids. No known cleaning method is 100% effective. It just doesn't exist. That's why that decision tree has so many clean, inspect, and inspect, clean, inspect, and connect. So many different times on that tree because nothing is going to be 100%. Improper cleaning can cause damage to the equipment. Now, I've talked about putting a little bit of pressure on that cube. I'm talking about a little bit of pressure. I'm not talking about scrubbing it like you're trying to polish it. I'm talking about just a little bit of pressure to help dislodge anything and give it a nice, smooth, even pressure. Don't go scrubbing back and forth over the same place. And you don't want to clean over the same surface. You always want to replace your wipe after you've used it once for cleaning. You just start cross-contaminating everything. Now, when you're storing your cleaning supplies and the little end caps, use a Ziploc bag or something like that that's going to be resealable and keep everything clean. Because those little end caps, you might inspect everything, look at it, and say, okay, well, I'm going to put the cap on this and store this connector for later, this patch cord for later. You don't know for certain you didn't just add contamination. On the flip side, when you pull out a connector and it's got an end cap on the ferrule, you don't automatically presume that that end cap was clean when it was put on, or frankly that the connector was clean when the end cap was put on. You always want to inspect before you connect. So if you keep everything very clean, you're going to cut down on this kind of cross-contamination. It's not to say it eliminates the inspection, but it certainly cuts down on the cleaning you will have to do afterwards. So a couple of slides to recap. We're going to talk about some nevers. Never use alcohol or wet cleaning without a way to dry it off. This will cause damage. Never look directly into a fiber while the system lasers are turned on. This will eat the back of your eyeball and give you spots in your vision for the rest of this life. Doesn't sound like any fun to me. I'm going to be very conscious about that and very cautious with my eyes. Never clean bulkheads or receptacles without a way to inspect them. Again, those little swabs can be ramrods. You could be making a bigger mess. And then if you don't inspect, you don't know for certain. So always inspect the bulkhead and the connector you're plugging into it before you make that connection. Never touch products without being properly grounded. Of course, that's talking about the electronic components in the racks. Never use unfiltered handheld magnifiers or microscopes. That one goes without saying, I guess, but I'm having to say it. They do make filters for different wavelengths outside the visible range. I find that the best course of action is to use a camera probe, so I'm not putting my eyeball up to it unless it's a patch cord and I've got both ends. Then I feel reasonably safe with a handheld magnifier. Never connect a fiber to a microscope while the laser is on. That's also talking about the probe. Now, if you shoot laser into the probe, you may damage the probe. I'm going to tell you the truth. I'd rather throw the probe against the wall than to get spots in my vision. So if I'm ever uncertain, I'm going to certainly plug it into a probe, not to a microscope. You always want to be diligent, but if a mistake happens, I want it to happen to the probe, not to my eyeball. Never touch the end face of the fiber connectors. Like I said, I've seen guys touching the end face. They'll drop a connector, pick it up, wipe it off with their fingers, wipe it off on their shirts. Wrong, bad, bad, bad. Don't be that guy. Don't touch the end face. Skin oil is actually a little bit harder to clean off than you would think it is. Never twist or pull forcefully on the cable. When you disconnect or connect the connector, you want to use the body of the connector, not the fiber. You don't want to go pulling it out. There's a weak spot right there where the bare glass goes into the back of the ferrule. We talked about that last month when we were doing the webinar on connectors. Never reuse a tissue swab or cleaning cassette reel. We talked about that a number of times already today. Never touch the clean area of the tissue. Once you do that, transfer oils, you get that smear that we looked at on that one slide. Never touch any portion where alcohol is applied. The skin oil will actually be dissolved by the alcohol and then wiped onto and applied evenly to the surface of the connector so that it can dry with skin oil nicely dissolved and spread evenly across the surface. That doesn't even clean up easily afterward. And don't touch the dispensing tip of an alcohol bottle. And never use alcohol around an open flame or spark. This is, again, one of those things I shouldn't have to say, but there's enough examples in the real world that demonstrate that I must. The alcohol is very flammable. It will go boom. So don't be that guy that looks like the mad scientist with the flash burns on his face and his hair pushed back, looking like a bad sci-fi movie. I've actually seen pictures of it. A guy spilled alcohol into a fusion splicer and sparked it. I got nothing more to say. Don't be that guy. All right, always Always turn off your lasers before you inspect the connectors, optical components, or bulkheads. Always make sure that the cable is disconnected at both ends, or that the card or pluggable receiver is removed from the chassis. Of course, both of these are about eye safety. Always wear appropriate safety glasses, and if you do have the laser safety glasses, make sure they meet all the federal and state regulations and that they match the wavelength of the laser you're using. Those laser safety glasses are so specific to one wavelength that if you're wearing 1310 safety glasses, they're not going to protect you against 1550. They're that narrow in their filtration. So for that reason, I usually find them pretty much useless unless I'm always working with the same wavelength. And I find that the best way to protect your eyes from exposure to lasers is to not look at the end of the glass. Just treat all fibers as if they're loaded firearms and expect that it's going to have light on it, and you will get through this incarnation without spots in your vision. Always inspect the connectors or adapters before you clean them, and then always inspect them again after you've cleaned them before you make the connection. Always use the connector housing to plug or unplug the fiber. Always keep the protective cap on unplugged fiber connectors. Always store those unused caps in a resealable container so as to not allow for contamination of the cap itself. And locate that container near where you're going to be working with the connectors. Always discard used tissues or swabs promptly after they've been used once. And that is it. So I'm opening up the question window, and I'm going to check to see if we've got any questions in here. Now, we did have a few questions that were emailed to us. So I'm going to go ahead and jump on some of those emailed questions and see what comes up in the question block here in just a minute. Now, this is an interesting question. There are some expensive cleaning systems. I'm not going to name any brands, but one of the models is called Clean Blast. And there's some similar products. And the question is, should the person buy one? Unless you're operating in a laboratory, this equipment is typically bulky. It is typically excruciatingly expensive. And for that reason, I find that it is, again, unless you're working in a laboratory environment, unless you are in production of patch cords and that sort of thing, I don't find that to be a cost-effective cleaning tool. Do you need special cleaning tools or materials for the APC or angled connectors? Technically, the answer is no, but it has been seen through experience. We were looking at those cartridge cleaners. Some of the cartridge cleaners are blue and some of them are white. The white ones typically have a higher thread count kind of lint-free wipe that the angled connectors will sometimes try to hang up on the lint-free wipe. So if you're using the finer grained wipes, they do work better. Also, LCs tend to be small enough that they'll stick on the cleaner. So you want to use that finer grain or higher thread count. Let's see, and another question is, do I have a recommended basic cleaning kit? Yeah, basically I think the kit that we showed in the picture, a cartridge cleaner, a quick click, Some lint-free wipes such as a cube. Again, I like that box because it has the rubber pad. Some swabs of the appropriate size, and a small bottle of some kind of non-flammable cleaning solution. And you put together a basic kit like that, and you can do 99% of the cleaning you need to do. And that'll all fit into just a small zipper pack that will go in your computer bag when you go out to the field, or in the bag with your OTDR. The cleaning products are very simple, and they're all working on the same concept. Now, see, we got a question in the question room. Let's see. How would you clean a bulkhead properly? This person normally works on dark fibers and notices that the bulkheads are always a problem and they cause reflectance or attenuation. Well, you get a probe and you look. What is the problem with these, with the other side of the bulkhead? Now, it sounds like you're doing similar work to what I do. You're going and testing other people's fiber. You're not allowed to unplug it from the back and get in there and clean the connector clean the connector well. So you're going to be using swabs and quick clicks. If you inspect it and it all looks like it's pretty much particulate matter like dust, then I would get in there and hit that quick click 4 or 5 times, re-inspect. And if it still doesn't come clean after a couple of efforts at the quick click, then moisten a swab, make sure you get it up in there and really get onto the Endface. Immediately get in there with a dry swab, clean it out, inspect it again, see how it looks. Because you're absolutely right, and that was what we were facing on that trip down to Haiti. We're going down there, we're plugging into their bulkheads. We're not allowed to disconnect from the backside because our world stops at their bulkhead. And so the only way to clean was with quick clicks and swabs. Let's see. Any other questions? Go ahead and get them in the question block. I do have another emailed question that I'm going to deal with because I think this is an important one. Do I need to have an MSDS for any of the cleaning products? And the answer is yes. According to OSHA regulations, you should have a material safety data sheet for any chemical that's being used in the field. They've got MSDS for whiteout and Sharpie markers. Of course, you're going to want an MSDS for the cleaning solutions. Go to the website for the manufacturer. Almost all of the manufacturers have the MSDS right there on their website. Download it, print it, make sure it's in your MSDS book, and you're covered for OSHA regulations. Let's see, another question in the question box. Do I recommend using chem wipes for cleaning of connector after termination? Now, I'm presuming that you're hand polishing the connector. Chem wipes are okay. I like the lint-free wipes that have a little more texture. I love chem wipes for bare fiber cleaning when I'm doing fusion splicing. But when I'm doing an Endface, I typically like something with a little more texture. So that's, my recommendation would be to get some kind of cleaning wipes, whether they're, they make all these that are in little dispensers, rolls in a dispenser with a little hole in the cap. You can also get the cube like we were looking at that has the roll that pulls out and over the rubber mat, or you can just get a package of wipes, the more textured wipes, and you can moisten those or use them dry as appropriate for your needs. Let's see, does the probe need to be cleaned, and does the probe transfer dirt over? In my experience, if you are careful about what you're doing and you occasionally clean the tips, the probe tends to stay pretty clean. And I am not aware of any example or any situation where I have contaminated a connector with the probe. But that is a very good question. You will want to occasionally wipe out those tips with a appropriately sized lint-free swab, though, just to be on the safe side. And let's see, can you use a probe? I'm guessing this is what they're asking, to check a jumper for breaks or problems. Or are we talking about no? I'm not quite sure what the question is, but a probe will not check it, but a visual fault locator, a visible red laser, is what you would need to check for breaks or problems, hard reflections that just will not clean, that sort of thing. You can look at the end face of a connector, look at the ferrule from the side. If you've got a visual fault locator plugged into the other side, you'll see a lot of reflection if there is a problem and it's not coming clean enough. But you cannot see breaks or anything like that with the probe itself. So, unless there are another couple of questions that come in the next couple of seconds, I'm going to say thank you to everyone that has attended. It's the holiday season, and you guys had a lot of things to do, and you had a choice about how to spend your time, and you chose to spend it with us, and we are grateful. And again, I wanted to say thank you to everyone for being with us today. If you have any further questions that come to your mind later, you can email those questions to training@fiberoptic.com. And you can look for this about a week from now. This presentation will be available for download, and that will be in the archive section by going to www.fiberoptic.com/webinar. So again, thanks everybody for being with us. I hope you have a great holiday season, and we will see you next month for our next webinar. Have a great day.